I have something with me and I'm going to show that to all of you. What's this? Any idea? What's this? Yes, Dhruv?
Sir, it's a motor.
Correct. It's a motor. It's a motor, right? But what exactly a motor is? Yes, Dhruv?
Sir, it helps a car move, car's wheels move if you click on the accelerator, or if you give battery to this motor, it helps the fan move. There are many kinds of motors
That's
exactly.
true. That's true. Absolutely correct, Dhruv. Absolutely correct. Not just, not just car. It moves almost anything. Anything that rotates or moves, it is because of a motor. Do you have the toy car? Have you ever played with the toy car? Right? So those wheels which are moving, it is because of this motor. Have you ever played with a dancing doll that moves around? Yes. So that is because of this motor. Uh, even how many of you have used the fan, the ceiling fan? Okay, many of you, majority of you. So that ceiling fan also moves because of this motor. Okay, so everything moves because of this motor. The water pump, maybe some of you would have seen the water pump, right? The submersible water pump that sucks the water and pushes at an upper, at a height. That is also because of, so that is also a motor. So all of these are actually a motor. Now, see how does it work? I'll show you. What you need to do is, you see there are here, yes. Now you see there are two tiny elements. Can you see those here? This one and this one. You see that? Can you see those? Yes. This one and this one. So you give the power to this two through a battery. Okay, a pencil cell or a 9-volt battery or a DC supply, whatever it is. So if you give the power, this will move. It moves. It comes into motion, and you attach a gear with this. It will turn almost anything. You can turn the wheel. You can make the disc that moves. You can make a lot of things out of that. This motor is part of Havi elements. This motor is part of Havi elements, and you can do a lot of experiments with Havi elements using this motor. Today, what we are going to do is, we'll see that why does it move. That is a big question. Okay, so here I opened a particular motor. I have a motor which is open, and you see this. So it's open now. Okay, I will remove something out of this. Yes. What's inside? Can you see? Can you tell me what's inside? Yes, Dharmansh?
Sir, I think so. Type of a magnet.
Oh, yes, they are magnets. Do you see there are two strips, two round
Yes, sir.
circled strips? Can you see those inside here? See this one, I'm pointing. So this way, this one, and this one. Do you see the circled plates, right?
Yes, sir.
So those are magnets. You are absolutely right, Dharmesh. They are magnets. Now, what does magnet do? Yes, Arohi?
Sir, magnets attract magnetic materials.
Exactly. That's true. So magnet attracts the magnetic material, right? If I bring something, so this is a magnet. If I bring something which is of metal, a magnetic material, it will attract, right? How many poles a magnet has? How many poles a magnet has? Who knows? Show me your hand. How many poles a magnet has? You know? Okay, Dhruv.
Sir, to north and south.
Two poles, yes, North Pole and South Pole. So imagine, see, I have this board here. Okay, this is a simple cardboard, it's not a magnet, but let's understand that this is a magnet. Then what will happen? If you cut this in half, or if you exactly, you are not supposed to cut, but you just imagine that this is part number one, then this, and this is part number two, then this would be one of them. Out of this two portion, this one, portion two. So this portion will be North Pole, and this will be South Pole. Okay, understood that? Now these poles can be of any it's not required that it would be always this two. It can be anything. Okay, yeah, see, Arohi is showing one magnet, North Pole and South Pole. You can see Arohi's video, and she is showing a blue and a red painted North Pole and South Pole. Now, okay, back to my video. I'll show you here. See here. So this will be the North Pole and this is South Pole. This is one possibility. Another possibility is, okay, in this case now, okay, you can keep it this way. Then this hole can be the North Pole, and the back side, this one will be South Pole. That is also possible. See, this is North Pole and this is South Pole. Yeah, so this is North Pole, this is South Pole, or this is North Pole and this is South Pole. North, South, North, South. So there are two poles for a magnet. Now I have two magnets here. Okay, I have two magnets. These are again cardboards. They are not real magnets. So you can try this yourself as well. You can cut the cardboard and understand if you don't have the magnets. Otherwise, you can try the magnets as well. So now imagine what will happen if I bring the magnet. See, now this is a North Pole and this is South Pole. And in this case, this is North Pole and this is South Pole. What will happen if I bring North to nearer to the south? What will happen? So if I bring North nearer to the south, what will happen? Show me. Keep your camera on and show me your hand. Keep your camera on throughout the class. David, Vaibhav, Pranav, everyone. Yes, Janil.
They stick together?
Yes, they'll stick together. They'll attract, right? They'll attract each other. There will be a force called attraction when I put North nearer to the south. And what will happen if I put North nearer to another North? What will happen in that case? Yes, Prarthana?
Sir, they will not attract. Yes, they will not attract.
They will not attract. But what will happen? You are right. Will not.
They will go somewhere else. Like if we will try, so it will happen somewhere else. It will go here and far, there. Far.
They will go far. Correct. Yes, Abhiram?
They will repel.
Repel. Correct. Repulsion. They will repel. Okay. So attraction, if the same, see, I'll share my screen to explain that. So we have a magnet here and another magnet here. And this is the North Pole. Yeah. This is the North Pole. and this is the South Pole. And here we have the North Pole and we have the South Pole. Now when the North Pole is with North Pole, they will go far. They won't come together. They won't attract each other. So what will happen? This thing. They'll go far. And that is called repulsion. And if they are different, if they are same, north-north, south-south, then repulsion, go away. And if north-south or south-north, if they are different, then they will attract. This will happen. Okay? Clear? I'll draw another magnet for that. See here. There are two magnets. And here is the north. Here is the south. Here is the north. And here is the south. So now there are different north and south. So they will attract. This is attraction. Yeah, this is attraction. Attraction. And this will be the repulsion. This will be the repulsion. Okay. Is that clear now for all of you? Any questions so far? Yes, Prarthana?
Sir, why just south and north attracts? Why north and north will not attract?
That is a very good question, Prarthana. See what happens that there are fields. See what happens that when in every magnet there are two poles, the North Pole and South Pole, there is it's actually a force. It's actually a force in which the, see like this, the electrons are arranged in a disciplined way like this. Okay. Now what happens that when the electrons are arranged in a specific disciplined way in a one particular direction, if the direction positive and negative, if they come together, they'll attract. But what if the negative comes together? Or what if positive comes together? If the electrons are in same direction, if here electrons are in the same direction, then what will happen? They will attract. But if they are in different direction, then they will not attract. It will cause a repulsion. So it's about arrangement of the magnetic field. Got it? Great. Yes, Dishan?
Sir, I have such a quiz of coding. If we can maybe play at the end.
Sure, we'll do that.
I just need to share screen.
Yes, no problem. We'll do that. Okay, Dishan? So you are clear about this attraction and repulsion of magnets? Okay, nice. Now, these magnets are attracting or creating repulsion, causing repulsion. Now I have put a structure and I am going to show that structure to all of you. You also can create this kind of structure yourself after the class for your own understanding. If you don't have the magnets, you can do something like this. And I'm going to show you that structure. Okay. Here. So it's a very basic structure. You can create that with a cardboard, some glue, and the ice cream or any sort of other sticks. Okay, see here is the structure. Do you see this? Two cardboards. Okay, here are two cardboards. Okay, now this is a North Pole and this is a South Pole. So what will happen in that case? This is North, this is South. What will happen? Yes, Dhruv?
So they'll attract and they'll stick
Correct.
if there are magnets.
Correct, they'll attract. But as you can see, I have put the stands here. Okay. I have put the stands here. So I have made them fixed. So even if they attract, they won't be able to move. Okay, clear? Because I have fixed them on a stand. Now, I have a wire. This is the wire, and I am molding this in a way, this wire, and if I provide current to both the sides of the wire, and I put them here, like this. Okay, see, like this. Can you see this? In between of the two plates. I'm putting in between of the two plates. First of all, can you all see this? Yes? Can you all see what I'm showing you? Just show me your thumb if you all can. Yeah, perfect. Now, okay. Okay, so yeah, it's a very basic structure. You can use the sticks and create something like this. See now what happens when you give the current. Okay, when you give the current to a wire, the electrons will pass, the current will pass from the one end to the other end. Imagine there is a battery, and if you are connecting the battery with the wire, okay, then the current will start flowing from one direction to another direction. One direction to another, one direction to another, one direction to another. And if you all know, we discussed this in one of the previous Havi camp, that when you give the current to a wire, it creates the electricity as well as some sort of magnetism. Do you remember that? That is electromagnetism. Yes, Dhruv?
I was saying that that electromagnetic field is created.
Exactly.
Right.
Electromagnetic field, electromagnetism. So this current creates magnetism in this wire. Now this, in technical word, this wire is called the armature. Armature, I'll write that in the chat so you all can read. Armature. Okay, so now this is an armature, and when it is inside, between these two plates, not exactly inside, but when it is between the two plates, two magnetic plates, two magnets with different poles, north and one, if one is north, another is south. When you move, yeah, I'll turn my camera again. Okay, here it is. So now this armature is in between here, like this. Now when the current is on, the electrons will start flowing through this armature in a direction, and that creates the magnetism. So for imagine this becomes a magnet now. There is a virtual magnet, an imaginary magnet, temporary magnet. Okay, a magnet will have again how many poles? How many poles the magnet has? 2 poles, north pole and south pole. So as this two magnets has north pole and south pole, this temporary magnet will also have the north pole and the south pole. So when it's inside, when the electricity is flowing, this is a permanent, these two are the permanent magnet, north and south, north and south. Now when the magnetism is generated, a temporary magnet has been created through electricity. Imagine that this has become north pole and this has become south pole. What will happen in that case? What will happen in that case if it is inside and this has become north pole and this is north pole and this is south pole? What will happen in that case? Yes, Satyam.
So they'll attract.
They will attract as well as they will repel. Both. See, this is the north pole. Am I right? This plate is the north pole and this plate is south pole. This one is south pole, this one is north pole. And here, now this one is south and this one is north. So north repulsion, south repulsion. So this magnet will turn like this. Okay? Because of the repulsion. Again, see, this is north and this is south. And this is north and this is south. So north repulsion, south repulsion. So this repulsion will create a motion. Will create a motion for this armature and it will turn. Oh, gone. Yeah? It will turn like this. Okay? So now this is creating the repulsion and attraction between the magnets. Now the magnets are already, this magnet is already turned. What if you change the current now? You switch the current from positive to negative. Just change the sides of the battery. If battery was in this way, okay, then if the battery was this way, you turn the battery the other way, like this. Then now the current was flowing this way, it will start flowing the other way. So now earlier, this was north and this was south. And now this becomes south and this becomes north. And since this is south and other side it is north, so again repulsion, again turn, it will turn again. Now you change that power, you change the battery again from this way to other way. So again repulsion, you keep switching the battery, you keep switching the current. So it will keep creating a repulsion force and this wire will keep moving and moving and moving and moving and moving and moving, and finally this motor keeps moving, keeps rotating. Now when you do this, what exactly the problem is? First of all, understood so far? Any questions so far? Everyone understood this? Very good. Fantastic. Now, next thing. See, is it really possible for us to keep switching the batteries every time? No. It must happen within microseconds and milliseconds, no? If you want to keep the car moving, this motion must happen in millisecond and microsecond, automatic, isn't it? Also, if you want to really run a car or a fan, the motor must move very fast, isn't it? So if you want to make the motor move very fast, you need to create the strong force. So you'll need strong magnets and strong wires. I'll show you that. See, do you see wires? There are so many wires. Do you see those? Yes, there are so many wires. Okay, now I'll share my screen. See, now here I'll just erase all this stuff. So now imagine that this is a magnet with north pole. Okay. Yeah, this is north, and we create another. See, this is north, and this is south. So this is fixed. You cannot change them. And you push a wire inside. You keep a wire inside. Now this wire, if the wire is thin, the magnetic field will be weak, like this. But if you put a lot of wires, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 50, 100 wires, 200 wires, then the magnetic field will be very strong. Now you keep not just one pair of hundreds of wires, means one set, not just one armature. What if you put two armatures together, two very strong armatures? What if you put very strong 3 armatures? What if you put very strong 4 armatures, 5 armatures, 10 armatures? Then the magnetic field will be very strong, isn't it? Yes, it will be very strong, and that makes the motor move so fast, very fast. And that causes the fan to move faster, our cars, the toy car, to any other motion toy that moves faster and faster because of a strong magnetic field. Is that clear? Now you see here in our motor that we have, okay, see, in this motor we have the 2 plates, north and south. One of them will be north, another will be the south. So these are the 2 magnets, and this armature, you see the coils here, the wires, very strong, so many of wires, and this piston, and most important, a ring, a circle, a ring. If you now you put this inside the magnets, okay, here like this. And if you give the current to this wires now through this plate. So here you see, when you give the current to these poles, okay, inside this is a brush. There are 2 brushes, and those brushes will touch. If you put this inside, those brushes will touch the motor, the armature, and your motor is done. Because of the magnetic field generated in the wires, in the armature, this motor will move. Okay, so that's all about how the electric motor works. Okay, so now we finish this class here today. Let's meet next Saturday in the new Havi camp. See you all in the next camp. Bye.